only thing that could do a weightlessness effect would be something having to do with magnetism. But to that point, in the drop tower experiments, there's a suppressed result that I stumbled upon, which is an experiment with various elements simultaneously lined up in a container that is fired up in free fall in a vacuum, and they do not all fall at 9.8 meters per second squared. They fall at different rates according to their composition, which in the video that I made, I speculated that it had to do with the atomic weight, but I think it also has a little bit more to do with the ferromagnetic properties of each element. But by the differing atomic weights and ferromagnetic properties, they fall at different rates in a vacuum. And that experiment was done in Bremen in Germany, maybe 12 or 14 years ago. And it's been suppressed. But it's a complete bombshell for their whole model.
Oh my, yeah. Is there any way that you could get me any source information on that, UAP?
Yeah, I'll see. I'll
okay. Well, the reason
send it to you here.
The reason I say that, I mean, because boy, what you just said, I don't know if you ever heard me talk about, alternative gravity theories and how I'm kind of backing the same idea that the Thunderbolts project is with, the electrostatic dipole alignment. But if you haven't, basically in a nutshell, what they're looking at as far as a model for that is obviously instead of gravity, which we know is nonsense, this, either Einsteinian with curving space or Newtonian with masses attracting to each other. The electric universe position on it, and I totally agree with this, is that what's actually happening is much akin to something that you can demonstrate with an old time television CRT, where you have the high voltage flyback transformers, and then they have, the CRT, and on the front of the CRT, you've got the static charge that's there constantly. And, as we all know, those of us that remember those old tube type TVs, anything, dust gets attracted to it, pieces of paper, all kinds of stuff will get stuck to it. So the premise is that there is nothing that is not affected in some way by electrostatic energy. And that can be demonstrated fairly well. So the idea behind this is that if the Earth is, we know there's an electrostatic potential to the Earth, right? And it's measured at about 100 volts per meter, et cetera. And so what they're saying is that you've got this huge electrostatic potential in the Earth, and they say 100 volts per meter going up to 50 kilometers is 5 million volts, et cetera. And what's going on there is everything that is within this field of this electrostatic field, and this is assuming, by the way, at least in my mind, that there is an anode to this circuit, right, being a firmament or something like that. So what's happening is that all objects, the Earth, everything in it, is within this electrostatic field. And so what's happening is the atoms or the molecules in our body and everything, of course, everything has a static potential charge because of, electrons or protons or whatever, everything is made up of atoms, right? So what they're saying then is that with the Earth being at this negative potential and the sky being at the positive potential, you can kind of draw an analog to it by saying that, okay, if I have a magnet and I sit it on the ground and I set the south pole down and that would represent negative, then you've got the north pole on top, then you basically can stack magnets, right? North, south, north, south, north, south. Well, electrostatically, this is exactly what they're saying is happening in this electrostatic model, that this dipole alignment is that our charge of everything is aligning in this way. And since it's such a weak force, it actually kind of creates a small bias for things to be going down towards the Earth. Because, density and buoyancy explain things very well, but there's still something that determines up from down, right? So, that would, going with that idea, that would tend to say that anything with different charge potentials would then have different accelerations down towards the ground. And gravity is really an acceleration, right? So, I mean, that's why when you said that, I'm like, whoa, that's amazing, because that is that is direct corroboration to the theory of gravity that I just described.
Yeah, yeah, and it's honestly makes more sense that way than their modeling of it. Which observationally, it's one of these things that they tell us over and over and over again, and that anything they do like that has to be suspect. Of the feather and the hammer experiment, the fact they did it on the moon, it should make everybody suspect.
Yeah.
Yeah, I'm looking.
Bob,
I'm looking for it.
I'm sorry.
I'm serious when I say it's suppressed. I can't even, I have it in my video list and I'm having trouble finding it.
Okay. Rob?
Yeah, what you were talking about would seem to make a lot more sense in terms of trying to create anti-gravity machines. Supposedly the Nazis were able to do that, the Nazi bell and whatnot, using spinning mercury.
Mm-hmm.
Like what you're talking about makes a lot more sense in terms of being able to create something that would be quote unquote anti-gravity, as opposed to the idea of gravity being associated with mass and that sort of thing. Yeah. That you're just basically switching the electrical properties.
Well, yeah, absolutely. Mm-hmm. And beyond that, Rob, another piece of corroborating evidence, I mentioned this before, is that they have noticed in shipyards, for example, where they weld these massive steel plates together, right? And of course, when they're welding them, they generate these huge magnetic fields, right? And they've noticed that when they have high charge potentials and high magnetic fields, that they've seen weird things, that these fields cause things to actually levitate, right? And beyond that, when you look around the world, you find there's several places around the earth that have these so-called gravitational anomalies. And, supposedly a lot of them have been written off to optical illusions, but there are still some that are really legitimate scientific, enigmas. And what they, when I looked into it a little bit, one thing that I found very interesting is that in these places where they have these so-called gravitational anomalies, they also have very severe magnetic anomalies in close proximity. And to me, when you're looking at the Earth electrostatically and electromagnetically, wow, this shines a whole new light on what could be causing this.
Yeah,
makes way more sense.
Yeah,
it may have nothing to do with it. It may have everything to do with it. But and if I'm wrong about this, somebody please jump in and tell me. But I had come across at one point this notion that Cairo, Egypt is basically the geographical center point of all of the landmass on Earth. Is that correct?
Yeah.
Yes.
Yep.
Okay.
Yes.
And so the Great Pyramid is at the very epicenter, and then it's something that has been an enigma, but also I believe I came across this idea that underneath they found some channels in different areas that had mercury, like pools of mercury, and different channels to route the mercury around in different pools for some reason that nobody understands. But
interesting.
That would be something, just I don't know, a clue maybe.
Well, yeah, that's why the Nazis were supposedly obsessed with that. And as I understand it, they had shipped it was at least one, if not a fleet of submarines full of mercury down towards Antarctica at the end of World War II.
Yeah. Yep.
Yeah, and maybe Ira knows, didn't a lot of them go to Argentina afterwards? But
I can invite you to my house at least.
Okay,
Absolutely.
so like, all right, so what goes up must come down. That's definitely a thing. And the Globers say that it's because of gravity and it's because we live on a ball, but we know that the Earth isn't a ball, and so there couldn't be something like gravity, and it's really not even necessary since, for what goes up to come down, it's not necessary for gravity on a motionless plane Earth. But in order for the whole density buoyancy thing to work, where helium rises and hot air rises, you still have to have a tendency for down to be down and for higher density objects to find their way in that direction. And it seems like if we're talking about like electric universe theory, then the magnetic sort of electromagnetic field of the Earth itself is practically causing this equilibrium. Because so for example, if you're in an area of the ocean and you decrease the barometric pressure, well, then the sea level is going to rise. But overall, you have this area of the sea, or the sea in its entirety, that's more or less flat. And I think that it's kept at that equilibrium more or less by the fields, by these invisible fields of the Earth, as opposed to anything like gravity. It's more of an electromagnetic thing. It's just for the tendency for down to be down, and everything else falls into place. It works very nicely, I think.
Yeah, I agree. Well, and not only that, when you start looking at the gravity experiments that they do inside of mines, when they go deep down in mines and they drop plumb bobs down in mines, right? Well, all of a sudden, the theory of everything being attracted to the dead center of the ball kind of falls apart. But again, in the electrostatic model, because the Earth itself is at this ground potential, of this large electrostatic, potential that exists between the Earth and the sky, suddenly then you can start accounting for other things to change gravitational pull, like maybe a large deposit of minerals or crystals or something. In other words, there's all kinds of things that could cause gravitational anomalies, instead of just simply mass pulling everything to the center of the Earth, which, by its very definition, there should not be any gravitational anomalies, when you're looking at it under that paradigm, right? So
yeah.
Right. Well, and I just think, and then so like you had mentioned, the different types of objects are falling at different rates in a vacuum, and to me that makes sense because intuitively, and we're not even necessarily talking about different weights of objects, maybe just different types of things and different densities of things, I imagine. I haven't seen the study. I'm just sort of speculating here. But it doesn't surprise me under this scope of, or under the lens of looking at density as sort of like a harmonic resonance to a certain frequency, as opposed to per se something to do with the atoms, in air quotes, being more tightly packed together, or whatever the explanation is. I don't know. It just makes more sense to me that perhaps there's more to different densities, or how density behaves, how density changes in density will cause reality to behave. There may be something more to that than just the physical aspect of the thing itself. Maybe it's something else.
Yeah, it's kind of like gyroscopic precession, but from the magnetic field in a way.
Right.
Because I've thought a lot about it, the up, down, where does it come from? And you see it with a magnetic field, and maybe it has to do with whatever is rotating, if it's the sun. And I think that explains the gyroscopic, or the precession that you see with the pendulum experiments. And it, that's a favorite proof of globe earthers. But if you consider, if you take the experiment, which is neither, and I harp on this all the time, it's not repeatable, it's not reproducible, but it is something that is observable. When it's observed, when you repeat the experiment, you don't get the exact same result. And when you reproduce it in different locations, it kind of follows their hypothesis. But of course, you can't test it at the North Pole or the South Pole. but anyway, there is a tendency of it to turn. And I haven't tested at the equator, but
there's supposedly
I haven't seen anything about it.
No Foucault pendulum at the equator. It won't work.
Yeah, it shouldn't work, but we don't know that. Sure. Maybe it does. Maybe it does rotate. Depends on the time of year. Maybe if it has to do with the motion of the sun.
Right. Well, there's also the Elias effect, that affects profoundly Foucault's pendulum, right?
During eclipses?
During the eclipses.
Yes.
Right.
And, where does that fit in?
Yeah, that doesn't fit at all.
No, but it does fit in an
It tells us about whatever's occulting the sun.
It supports the idea that the sun and the moon are potentially electromagnetic, and everything is electromagnetic based, and that when you get that alignment, something's going on with the ether, right? I mean, to me, that's what that says, and I've never seen it done, but I have read about what happens to these Foucault pendulums during eclipses, and it really only supports the hypothesis of a stationary plane Earth with ether and celestial quote-unquote objects that are in circular motion.
Well, plus with every Foucault pendulum, and I have never seen one that does not, they all have a magnetic mechanism which causes it to kick the pendulum back into motion, because otherwise it would just stop after a little while. So it's all got this mechanism that nobody knows, who's installing these things, how do they work, how do they know which way to kick.
Exactly.
Yeah.
And that kick is going to have a magnetic field that's going to rotate it as well.
Right.
And something that caught my attention is in the best place to prove the efficiency of the Foucault pendulum will be in the equator, and there is none. All the pendulums are in in the south and north part of the supposedly sphere, but there is none, or at least I never saw Foucault pendulum in some place on the equator.
Well, I think
the country of the equator.
I think they say, because I thought it was that way too, but I think they say that there would be no motion at the equator.
Show us.
Yeah, but they say the poles it would be there, but of course you can't go to the poles.
Exactly, but if you put some pendulum on the equator and you make that your push, and you have that supposedly non-rotation thing, well, that will be a nice proof to to validate the other pendulum. But on the equator, they only show a touristic show where you go, and some guy drop a water, so put a pendulum on there.
Well, I've seen the Foucault pendulums that supposedly tell time too, right? It'll swing and it'll knock over a little peg, and that'll be the hour of the day, which is just ridiculous because it would have to be made for the specific location. So obviously the kicking of the mechanism is programmed to the time. I mean, that's the only way that would work.
Exactly. It's a demonstration. It's not an experiment.
Correct. Absolutely.
If there's one thing that I would say that would give any weight at all to the Foucault pendulums argument, and not in the heliocentric model, but looking at it in the flat Earth model or the electric universe model, there are these things that are called Birkeland currents, and they've discovered that. I mean, first of all, these things absolutely exist, and starting from the North Pole going outwards, towards the edge of the disk, you basically have counter-rotating electrical fields. You have one field going clockwise, the next counterclockwise, the next clockwise, and it's very possible, I would think, that where a lot of these Foucault pendulum demonstrations are set up, the government likely knows where a lot of these counter-rotating electrostatic currents are occurring, not only in the United States, but anywhere in the world that they're having them. And it's likely that they're building them on top of these areas, which have a bias, to swing the pendulum in the proper direction, and things like that.
Right. Because you just only need a nudge, right? Just a minor tendency for it to, yeah.
And that's assuming there's any credibility to it. But but I've tried to kind of figure that out. And, that seems to me that it's at least reasonable. And it also would explain why, during eclipses, where there's obviously an energetic block, that it can kind of change that potential as far as what is affecting the pendulum in its rotation. So again, that kind of makes sense to me, but what do I know?
Well, that's an experiment that could be done on the equator, on the equinox, and then either winter or summer solstice, to see if the pendulum would move differently.
Well, how would you keep it moving?
Well, do it the way that I would just do it the way that they say that they can do it.
Well, I think they do it with a magnetic device, and I think that immediately causes issues, at least to me.
Well, no, but what I mean is, you have a really heavy object and a really long cord with a unbiased pivoting thing, and let it go, and then of course it's going to wind down, but it's going to process or not. And it would be interesting. My hypothesis would be that, let's say you do it in late December, and you're doing it right on the equator. It's going to follow the tracking of the sun around, and then you do it again in June, and this time of year it might go. It might go the same way, and then you do it on an equinox, and it may just be straight. It may just swing straight, or maybe process ever so slightly just because it hit a gnat on the way or something, just to get it moving. But my hypothesis would be that it would tend to follow the position of the sun. I think that's what's always going on.
Yeah.
Right, like the Coriolis force, same thing. It's going to do the same thing.
Mm-hmm.
Yeah.
Yeah, and the Coriolis, of course, the biggest thing that the Globers will defer to is the spinning direction of storms, of hurricanes, in the southern hemisphere as opposed to the northern hemisphere. Even though there are rare occasions when you will get one spinning the wrong direction in the wrong hemisphere, but overall they're fairly consistent. And again, this would go with the idea of a Coriolis type effect.
Ran downstairs to grab a book when you guys were talking earlier about the Foucault pendulum, because I just read something last night in a book. It's called 50 Reasons Copernicus or the Bible by F.E. Pash, copyright 1915. And regarding the Foucault pendulum, he talks about this guy, Dr. Schopfer, I think is how you pronounce it. Anyway, he was an eyewitness to the original experiment by Foucault, and he says, quote, in an introductory speech by Dr. Menzer at Coldenberg or something like that, showed that until then, there had been no proof for the Copernican hypothesis, the so-called proofs being, after close investigation, just as many confutations, until the Foucault pendulum showed the rotation of the Earth uncontrovertibly. The pendulum was tied, the string was burnt, the swingings began, but the pendulum deviated to the left instead of to the right. It was hastily brought to rest. New burning of the string. This time the deviation was the one desired, and we were invited again to present in the church the next morning at 8 o'clock to be convinced that the deviation agrees with the theory. On the following morning, however, we saw that the pendulum during the night had changed its mind and had, from the deviation to the right, again returned to the left. To me, this seemed new proof that did not seem to be quite in order. My belief in the Copernican doctrine was shaken by the speech of Dr. Menzer, and I concluded to go to Berlin for an explanation. After seeing the pendulum experiment here also, and strangely again with the deviation to the left instead of the right, I went to Alexander V. Humboldt, who was indeed over the first refuge of those seeking information. He received me very friendly and spoke the memorable words, quote, I have known too for a long time that as yet we have no proof for the Copernican system, but I shall never dare to be the first to attack it. Don't rush into the wasp's nest. You will but bring upon yourself the scorn of the thoughtless multitude. And it goes on to talk about every time they initially tried it, it wasn't giving the results that they were wanting. In fact, it was often going the opposite way that it should be going. So they would stop it, try it again, we got something wrong, and then would set it in motion, and then overnight it would revert to going the wrong way.
So
that's classic.
So Rob, I'm actually looking at while you were saying that, a 3B scientific physics. It's a $6,500 Foucault pendulum you can purchase from Amazon. It's in a big glass case. And as I'm reading it, it's basically telling you how to do these experiments in front of students. And it says exactly what you said, that set up the Foucault's pendulum on a horizontal surface, using your hands, check the housing for vibrations, and then it says that you want to let it go. And if it doesn't go the right way, then the test needs to be stopped and restarted. It says when the swing.
Notice how they don't say, go ahead and push it a little bit to the right. They say, if you don't get the results you want, keep doing it. But essentially, they could just go ahead and say push, give it a little bit of a English to the right. Right.
Yeah, and it says here an electromagnet with a radially symmetric magnetic field is mounted exactly in the middle of the pendulum's path. The magnet only has an effect when the pendulum is moving towards the center. The electromagnet is controlled by a photovoltaic cell, which registers the shadow of the pendulum motion by the light provided by a built-in fluorescent lamp. The pendulum is excited in a way such that its amplitude remains constant. It's just funny. I mean, all these things have to be included in it.
Yeah, I went to the Griffith Observatory where they have that, pretty famous one there, and I'm in line with the tour, and the tour guide in the middle of the presentation says, "Yeah, and to keep this thing going and everything, there's an electromagnetic motor up there on this special, gimbal swivel, deal," and she just kept going, like, "Okay, we're telling you this thing is being moved electromagnetically with a motor up there," and it just kept going. And so they had this little model over on the side of a globe with a little teepee on it and a little hanging pendulum. So I went over to the model, and another tour guide came over and saw me looking at it, and they said, "So do you have any questions?" I'm like, "Yeah, can you explain it to me again? I heard what the other tour guide said," and he went into even more detail and again pointed up and said, "Yeah, there's a motor up there, otherwise the thing stops," and there's all. I'm like,
well, this one here
doesn't that defeat the whole purpose of what this is supposed to be doing?
Totally. It says here, if the experiment is conducted with excitation, then the amplitude must be observed for approximately 5 minutes, and if required, should be corrected using the excitation adjustment switch. So then there's a switch that can displace the pendulum bob by hand and release it. During the experiment, the pendulum must swing in one and the same plane. If it begins to swing in an elliptical path, the experiment must be stopped and restarted.
Yeah.
Matthew love that overly complex euphemism.
Yeah, no,
and that's it's a curious thing because the elliptical path is the path of the sun.
Oh man, these guys.
Well, yeah, but to Bob's point, I think it would make sense that they would try to eventually figure out these zones, if you will, where it would give you the results that you want more consistently. And in the beginning,
Right.
they were just thinking in principle, hey, let's try this out, but it's going left, it's going right, it's going, until they probably through trial and error maybe have figured that out.
Yeah, in the early 18th, the mathematicians Mach, he pointed out that you can have the same effect if you have a rotational firmament, the drag of the ether.
Right.
So,
the ether. Right.
Exactly. He disproved.
Yeah.
In those days, I think that is why they the same guy who invented the pendulum is the same guy who needs to invent the gyroscope, because I think that at that time the scientist community, they just say, okay, this pendulum, man, you need to push it for yourself. It's a stop. They can go in any direction. So we need to invent something else because this is not proof nothing. So the same guy in that period of time was the most, the most list of experiments to trying to detect the motion of the Earth. The pendulum, the gyroscope, the Sagnac experiment, the Michelson-Morley, the Michelson-Gale, and all fail. Or I mean, all give us that the Earth is motionless.
Honestly, I don't even see, like, if you get perfect results on one of these pendulums, I don't see how the results lend themselves to a spherical spinning Earth unless you were standing right on the North Pole. To me, if you were standing somewhere near the equator or tropical or whatever, I just honestly don't see how spinning around the axis, as they say, would translate to that pendulum going around in a circle. Like, I honestly, I don't see it.
I agree, John. I so agree.
Yeah, completely
That's
different.
never made any sense to me.
They claim
it's smoke and mirrors.
It's the latitude that you're at. So if you're at 35 degrees north latitude, you'll have a different period of motion than if you are at a, let's say 55 degrees north, it'll be a different period. And so they say that they can calculate within 2 degrees the latitude just by the entire period of not gyroscopic precession, but the precession of the Foucault pendulum. Now that's a claim that they make. I haven't seen it made.
Well, and to me, what jumps right out, and just like it always does, is the fact that they claim that this behavior of the gyroscope is exclusive to a globe, and of course, I don't think that's exclusive to a globe at all. Did I cut out?
Right.
No, I
Right.
thought we lost UAP. I'm sorry. Go ahead, UAP.
Oh, I was going to say that if it is something that would bear out, which again, I reject the premise because it's not a repeatable and reproducible experiment, not to any kind of statistical standard that is accepted otherwise. But okay, let's accept whatever it is here, the significance of it. You could explain it in other ways. They only want to consider their one hypothesis. So it could be proximity to the sun or a number of different things like that, like you mentioned, that could explain a varying rate based on your latitude of the experiment. And I use the term loosely of experiment because, like you said earlier.
Well, I mean, if you assume, let's just go the other way for a minute and assume, for argument's sake, that there is a magnetic vortex that's centered on the North Pole on a flat Earth, then the vortex itself of that field would be going at a faster rate through space at the latitudes further and further south. So as you go south, that the velocity should increase. And to me, that explains it very nicely, why you would get that sort of gradient in velocity of the pendulum with latitude, respective to latitude, rather.
Yeah. But and I don't think that it's had enough analysis, especially with the aberrations you get when you have eclipses, because that that should have nothing to do with it if it's motion that they're talking about. But in my mind, it absolutely proves that it's an electromagnetic phenomenon.
Yeah, agreed. I just, like, if someone were to 3D model what's supposedly going on in that pendulum, I'd love to see it, because just trying to visualize it, in 3D, which is a little bit hard to do, I could see that sort of thing working on a stationary Earth that's not orbiting the sun or anything, but and where the pendulum is just right on top of the North Pole. And the Earth spins once in 24 hours. Then I could see their data aligning to that. But then anything where you're supposedly, perpendicular to the axis, or some degrees off to the axis like that, spinning around at 1,000 miles an hour or whatever, I just really don't see how you would get anything but a pendulum that tends to swing east to west and stay in that configuration. But I don't know.
Well, it's
a phenomenon that they want to consider for that, but then for everything else, they don't want to consider it. And I think one of your videos, John, you had a good demonstration of the moon around the Earth and how the moon kind of stands still for a while as the Earth's revolving around the sun.
In terms of like orbit,
Yeah. And so you would have those influences where that would absolutely yank everything to the side. You'd feel butterflies in your stomach in a way. It's all over a slower timeline, but we don't see it considered for anything else. And in the Foucault pendulum, of course, there's no mention of the moon and its effect that, of course, that would have some influence, you would think, on it.
And I must be disappoint you, John, because the 3D software, when you start doing it, dynamics simulations, they consider the gravity as a linear force. So if you put a pendulum perpendicular or oblique to a surface, immediately the pendulum is gonna rest like it's like it's gonna be straight. You can do spherical gravitational force towards a center of the supposedly 3D world. So anything you do on the computer dynamics, they assume like the gravity force that you can simulate is like a straight line towards the flat surface. I don't know if you understand what I'm saying.
So you can't model a gravity situation in 3D where it's going to the center of a ball.
You can do it, but you must be put so strength, so powerful, that force, that you can even move the rest of the pieces, because you have like a big magnet, so you can move freely, like supposedly happening in the real life.
Yeah, and no, that makes sense too, because there's no real application to have any sort of spherical gravity, even in theory, but it makes sense that they wouldn't have it, because in practice, I just don't see it ever being needed, unless maybe for like a video game where you're traveling through to planets or something, but even then,
yeah,
I don't know.
but in that case they fake it. I mean, they just put some special numbers to emulate that behavior, but you don't use two forces to simulate gravity in 3D software. You just only account for a straight line to the floor, and the floor of course is flat. You don't have these split forces, because if you are, I don't know, for example, now right now, me in Argentina, supposedly I am attracting to the center of the sphere, the gravity must have like two vectors, because I had also to fight with the centripetal force and all that kind of things, and that is not the case in the dynamics of the 3D softwares.
Right.
Yeah, it makes sense.